Hi, you guys. I want to make a video regarding the characteristics of the graphs of f prime and f double prime, or f in the first and second derivative graphs. The first and second derivative graphs can give us the information that we need to draw the original graph of the function, even if we do not have the equation. If you guys recall from class, I gave you what I keep referring to as the elevator packet, where we tried to go through different ways to see the relationships between the first and second derivative graphs and their relationships to the very first graph. So I'm just going to go over that chart very quickly before I do the videos on our f to f prime or f prime to f homework 1 through 4 problems. Actually, I'm only going over 1 and 2, and hopefully you guys will do 3 and 4 for your homework. So let's start off with looking at f, the characteristics of f and how they relate to f prime. I know that the graph of f will be increasing whenever f prime is positive or above the x-axis. And I also know that f is decreasing wherever f prime is negative or below the x-axis. So for f prime to go from being positive to negative, it must go or pass the x-axis, which means that it has an x-intercept there. That means it will be equal to 0. So whenever this is equal to 0, or let's say if it does not exist, then that means that I will have a critical point in my original graph, which means I'm either going to have a max or a min. And the cool thing about this relationship, oh, by the way, that's a possible critical point. We have to do a test to see if it is actually a critical point. The interesting relationship between this f and f prime is that it can be shifted down, and there's the same relationship between f prime and f double prime. What do I mean by that? I mean that where f prime is increasing and decreasing, then in the graph of the second derivative graph, this is positive and that's negative. And also wherever the second derivative is equal to 0 or does not exist, I am going to have a possible critical point in the first derivative. A possible critical point, which means there's going to be a max or a min. But then this information from the second derivative, remember, it tells us about our concavity. It tells us about our concavity of our original graph. So whenever the second derivative is positive, my first derivative is increasing, and my original function is going to be concave up like a cup. Whenever the second derivative is negative, the first derivative is decreasing, my original graph is going to be concave down like a frown. And wherever my second derivative is equal to 0, and my first derivative is going to have a max or a min, I am going to have a possible point of inflection, meaning changing from concave up to concave down, or concave down to concave up. So hopefully we will keep these in our notes so we can go back and refer to them.